4.4, using corresponding parts of congruent triangles. We're going to call corresponding parts of congruent triangles congruent CP-CTC. So corresponding is the C, parts is the P, the of doesn't have one, congruent C, triangles is T, and then our congruent is going to be added to that. And that's the other C, so CP-CTC. Jot that down in your postulates and theorems, even though it isn't one, just so you don't forget the letter order. We're going to be using CP-CTC today to prove other parts of triangles are congruent after that as well. So first one, proving parts of triangles congruent. We're going to do a little proof here. It's going to be 4 steps long. Step number 1 is the given, as always. Angle KBC congruent to angle ACB, given. Angle K congruent to angle A is also given. I'm not sure why this is blinking today, but I'm going to keep going and see what happens. So we have an angle marked, another angle marked. The only other way that we can get anything marked, we don't know that the lines are parallel, so we can't use the other angle. We don't know that the other sides are marked the same. The only side that we do know is BC congruent to itself. And that's reflexive. Property of congruence. Now that we know that, the triangles are congruent. Triangle KBC congruent to triangle ACB, and it's angle side. Since we have an angle, another angle, and a side, and the same in the other one. Once we know that the triangles are congruent, everything about them is congruent, so we can pick basically any other part and say that it's congruent to its corresponding part. And so the last reason, CP-CTC. Here's another one that we can try. This is just for the advanced geometry students. This one is also 4 steps. So pause it, try it, see if you get it. So this proof is 4 steps long. So you'll get your statements and your reasons columns. Your given is always step number 1. Sometimes the book will put the given in separate steps. I always put them together so I know I have them. Okay, so I'm going to check to make sure they're marked in the picture. Segment BA is a single hash mark. Segment DA is also a single. CA and EA are both double, so we're good there. We don't know anything about parallel lines, so we can't have any other angles the same. But we do know that those two are vertical angles, so those are congruent. Since they are touching at the vertices, we have to name them with 3 letters. I'm going to go with angle BAC, congruent to DAE, and that would be vertical angle theorem. Once we know that those are the same, the triangles are congruent, we have a side and then an angle and then a side. So they're congruent by side, angle, side. I'm going to use the same letter order as I did on the angle previous. I'm going to go triangle BAC, congruent to triangle DAE, side, angle, side. And then step 4, angle C is going to be congruent to angle E. And the same reason as the last one, corresponding parts of congruent triangles are congruent. Long question on problem 2. It's on page 245. Yep, I did have the picture, but that's where you're going to find this one. I don't know if it's Thales or Ty, a Greek philosopher, is said to have developed a method to measure the distance to a ship at sea. He made a compass by nailing 2 sticks together. Standing on top of a tower, he would hold one stick vertical and tilt the other until he could see the ship S along the line of the tilted stick. With this compass setting, he would find a landmark L on the shore along the line of the tilted stick. How far would the ship be from the base of the tower? Thank goodness they gave us a picture, because that's a lot in one paragraph. So in the information, it gives us angle TRS and angle TRL are right angles. Angle RTS is congruent to angle RTL. Those are the 2 angles at the top. They want us to show that the base angles RS and RL are congruent. So we start with the given. I'm going to do all the given in one. And if you want to look at the picture in the book right now, it is again page 245. I'm on different pages now, so it might be hard to figure that out. RTS, congruent to angle RTL. And angle TRS and angle TRL are right angles. So don't forget that part, even though it's kind of specified in words. Now, since the triangles are side by side, there's always a reflexive property of congruence. And I'm going to go with TR, congruent to itself. Don't forget the symbols. So far in our picture, I'm going to just draw a quick little sketch of it. Those are right angles. The angles at the top are the same. So we just did this one. So we have an angle and a side. We do have 2 angles marked with right angles, but we have not specified that they are the same. So those 2 right angles are the same. All right angles are congruent. So angle TRS is congruent to angle TRL. So now this one is the same as this one, and we do have congruent triangles now. Triangle TRS is congruent to triangle TRL, and that's going to be angle, side, angle. If you remember, look at one triangle and do them in order. You'll figure out which one it is. And when that happens, all the other parts are congruent as well. By corresponding parts of congruent triangles are congruent. Here's a got it question. AB is congruent to AC. M is the midpoint of BC, and I like these because they're doing a couple of different things that you haven't seen in a while. So I'm going to put the given in here right away. And abbreviate just a bit. So AB is congruent to AC is marked. M is the midpoint. Anytime you see a vocab word, you're going to use definition of that vocab word. So you have to think about, what does midpoint mean? It means it is in the middle. So this small segment is congruent to this other small segment. I'm going to say segment BM is congruent to segment CM, and make sure you pay attention with letter order. So we have 2. We also have the side-by-side thing going on, so we know we will have a reflexive property. You can't assume that these are right angles unless they tell you they're something perpendicular or that they're the same. So you have to go with the things that you absolutely know. So AM is congruent to itself. The triangles are now congruent by side, side, side. So triangle ABM is congruent to triangle ACM by side, side, side. And the last angle that they want to be the same is now congruent by corresponding parts of congruent triangles again. Okay, so geometry students, that was a lot of proofs for you. You guys do not have to do the proofs, but I did want you to see and look back at this reason, because you will use this reason in your proofs as well as the advanced students.